Hi, I'm Doug Smith. I'm in the Boulder Dam Hotel in Boulder City, Nevada, and I thought I would do a little experiment for you today with current probes to show where you should put BNC feed-thru 50 ohm terminations to adjust the frequency response of the probe. Now, I cover this in great detail in my seminars, but I thought I would show you a technique, or at least where to put these terminations and what effect it has. So let me first go down here and show you a diagram of what we're going to do. There we go. So we have a wire carrying a current from a little signal generator I built. We have a current probe, which is a Fisher Custom Communications F331, and I've got 4 50 ohm terminations either on the probe or at the end of the 50 ohm cable at the scope, one place or the other. We'll see the effect. And this tends to modify the frequency response of the probe, reduces sensitivity, but gives you response to lower frequencies, and for some reason you may need to do that. So again, these are composed of 4 50 ohm resistors to ground inside these terminations. They're not a match impedance termination, just 50 ohms to ground like we used to use on the inputs of scopes a long time ago. So the question is, does it matter which side of this do I put it on? So let's look at the test setup, which is right here. So here's the output of the signal generator here. It's this little one that I built. It's running about a couple megahertz. It goes through this wire, through the current probe, and in to ground. So little current loop goes here. I've got the terminations installed in the probe here now. And if I turn on the oscillator and then go back over to here, you can see we have a current waveform. This amount of current is about 40 milliamps. The short circuit output of the oscillator is 40 milliamp current with a few nanosecond rise times. So we're at 10 milliamps per division, but those resistors reduce the sensitivity. So this is 40 milliamps, and we're at 40 nanoseconds per division horizontally. So this is, in terms of the actual probe response, this is about 20 milliamps per division here. Now, if I take those terminations you saw in the current probe, and I'll take them off here, put the current probe on directly, things get a lot bigger, but the waveform is not very square anymore because of the low frequency response of the current probe. Now I'm going to move the terminations to the scope, which is actually in back of this display. You can't really see it. Now it's on the front of the scope. And you see now we have a bump here. So the output from the current probe sees the 50 ohm termination, but then it sees the 50 ohm cable, I should say. Then it sees the lower 10 ohm termination at the scope, 4 times the 50 that I put in parallel with the 50 of the scope. So the probe seeing actually the end of the cable seeing 10 ohm load, the probe used to see the 10 ohm load. And so we get this reflection here, which is a problem. It's not as good as the real response, and of course it's not reflective of the real waveform. Let me put it back where it was on the probe. Take it off the scope. Put it back on the probe. And now we go back over to here, and you see we're back to a nice waveform. So if you're going to add feed-thru terminations to a probe to change its frequency response, it should be at the probe end, not at the scope end, because it unbalances the 50 ohm cable, causes a reflection when you use it that way. So ending up here, I'm using here, I can't quite see, it's sort of in back of the display here. It's a Tektronix MDO 4104B-6 scope that we're using. And this is an old monitor from a PC, just to get a bigger display. So thank you for watching. Maybe you can get to Boulder City sometime and visit me. Over there in the background is a classroom that I used to teach with, and we're in my lab right now where we do the experiments. Thank you for watching.